All right, welcome to Tellefsen Physics. So once again, we're going to do another experiment looking at how cars interact. So this time it's going to be a little bit more like a car accident where the two cars come together and they attach to each other. All right, so fenders don't bounce off each other, you become attached, and we'll see what happens. All right, so once again, just to remind you of the setup, I have photo gates here. These flags block the photo gate light so that we know how long, I can do it with my finger too, how long the light is blocked, but I know the distance of my flag here. And so my flag's just post-it notes in this particular case. So we're going to do a couple experiments. I'm going to take the blue car, and that's going to be 250 grams. So I'm going to call that one mass unit. And I'm going to crash it into the red car, which is also one mass unit. So the total mass units will be two masses when they connect, and they'll travel together, and let's see what happens. I think you could probably predict what's going to happen. So think about that. What's going to happen to the speed of the blue car? The red car is also going to change speed. It's not moving. Okay, so let's take a look. Let's give this a push. Let that go through, and the flag goes through twice. At first it said 0.23, and then the second one said 0.20 because there is friction in the system. I do have some friction. So actually one of my experimental designs is I try to put these as close to the cars as possible. All right, so the blue car went, well, let's just write down the actual numbers. Went 0.5 meters per second, and the first flag that went through said 0.23. So that's about a 2-to-1 ratio. This is a 2-to-1 ratio. Interesting. All right, so now let's make, so like we've done before, let's make the blue car more massive. So now the blue car is 2 mass units, so 500 grams in this particular case. Then the red car is still 1, and so what will collide will be 3 mass units. All right, so let's put that there. Let's try to put that as close to my photo gate as possible, and then give it a push. I'm going to stop it there so it doesn't change my numbers. And so what do I see? So I pushed it a little less this time, but that's okay. No big deal. And then 0.26. So half of 0.43 would be 0.22. A little bit. We see a little bit of an effect. See if that effect is still, let's just do it one more time. Let me push it a little harder. Let's see what happens. Stop it. Yeah, about the same. We had similar numbers, so I'm good with that experiment. And so we do see that the blue car slows down. That's what we expect. Half is 0.22. It's a little above half, and I expect that as well because I'm going from 2 mass units that's moving to what's 3 mass units. Not quite as pronounced as it was before. Now let's take that mass and put it on the red car instead, and we'll have the much lighter blue car. So the blue car is 1 mass unit, the red car is 2 mass units, so now we've got a 3-to-1 ratio. So think about what's going to happen to the total speed. Let me put that close to the photo gate, and let's give it a push. Stop it. All right, so the blue car, I give it a bigger push that time, a little easier to push with less mass, less inertia. And then what's that? 0.22. So what is that? So that's really, really close to 3-to-1, which is what I see here. So why are we seeing all this? Well, this comes down to something known as conservation of momentum. So in this particular case, I have a system of 2 cars. I do have a force between the 2 cars, but if I consider this a system, then I can use something known as conservation of momentum to figure things out. So I can look at the momentum before the collision and add up everything that has momentum, so sigma, and I can add up everything afterwards. Matter of fact, let's get rid of the deltas for this purpose. I'm not actually talking about change of momentum, I'm talking about absolute momentum. Change of momentum is final minus initial. We'll come to that some other time. And so what does this mean? So mass times velocity of everything at the beginning, added up, equals mass times velocity of everything at the end. All right, so I can actually consider, right, this is 3 mass units moving together after it collides. I have 1 mass unit going in, so let's think about what that means for the last one. 1 mass unit here goes a certain speed. In this case, it was 0.70. Then, when they collide, it adds up to a total of 3 mass units. So the only way to make this equality work is that that has to be cut threefold. And that's what we saw in these results. All right, so this is known as an inelastic collision when 2 objects stick together, essentially. And so we'll be looking at this in a more mathematical context later. All right, so we've seen our inelastic collision demonstrations. And so now let's think about what we saw and what it means. So what happens when one car is pushed into a stationary car and then they stick together? So think about it when they have the same mass. Think about it when the cart that's being pushed has double the mass of the stationary cart, and think about it when the stationary cart has double the mass of the pushed cart. Hit pause, think about it, then hit unpause to see the answers. All right, so what we see here is that when the carts have the same mass, they're going to combine and they're going to slow down. How much are they going to slow down? If the 2 carts have the same mass, so 1-to-1 ratio between them, that means when they combine, it has double the mass compared to before. And so the speed is actually going to be inverse to that. And so it's going to slow down half. Now, what about if you take the more massive cart and have it as 2 mass units and it collides into 1 mass unit? Well, the combined is going to be 3 mass units. So it's a 2-to-3 mass ratio before and after. But the speed ratio is it's going to be going fast and then it's going to slow down. So it's going to be a 3-to-2 speed ratio. So if the cart by itself is going 1.5 meters per second, when they come together, they'll be going at 1 meter per second. Now, if the stationary cart has double the mass, it's going to slow things down more because now you have a 1-to-3 mass ratio compared to beginning and end. And so the speed is going to slow down by 1/3 as well. So we'll look at this in a more mathematical way, but we see that whenever these carts combine, the overall thing is slowing down.